the difference between probability and odds. I alluded to this very briefly yesterday when we were talking about the probability of a coin landing on a heads or a tails, I can't remember, and someone said it was a 50-50 chance. And I said, that's actually the odds, not the probability. Okay? So odds are very, very, very much connected to probability. If you know odds, you can calculate probability and vice versa. But we are going to learn sort of the nuances of the difference between probability and odds today, and then we'll go from there. Okay? This is a really easy thing to mess up if you don't practice it a little bit, because people in everyday life tend to think that probability and odds are kind of the same thing. Okay? And they sort of are because they express the same information, but they're done in a different way. And so if you get a question on odds versus probability, you better be clear about what odds are, because if you answer it as probability, it will be wrong. Okay? So let's just start with probability. Okay, let's make sure we got that down. Standard six-sided die is rolled. What is the probability of rolling a 4? Okay, so we have been through this all before. Hopefully you guys know if you're rolling a standard six-sided die, probability of rolling 4 is 1 out of 6. Okay, but how did we mathematically calculate this? And we're doing it on a simple level so that we can apply that to more complicated questions. We looked at the sample space. So the sample space of rolling a six-sided die is 1 through 6. Okay, favorable outcomes in the sample space is 4. That's the only favorable outcome. Okay, if all outcomes are equally likely, which they are in this case, then the probability of rolling a 4 is the number of favorable outcomes over the total outcomes. And that word total is an important one when it comes to probability. So that's 1 out of 6. Okay? Any questions with that? Pretty straightforward. Okay, I'm going to skip this next one because it's very similar, and I think we all have a pretty good handle on this. Okay, let's take a look at a couple of these guys. So a student can win a trip to Hawaii if they pick a red ball from a bag with 1 red ball and 999 black balls. Okay, what is the probability that the student will win the trip? 1, yeah. So P win is the number of favorable outcomes to winning. Favorable outcomes is picking the red ball. Okay? There's only one of them. Out of the total number of outcomes. What's the total number of outcomes? 1,000, because there's 999 blue plus the 1 red. So this is 1,000, right? Because this comes from 999 plus 1. Okay, good. Number 2, a bowl has 10 hazelnuts and 8 almonds. What's the probability of reaching into the bowl and getting 1 almond? And for simplicity's sake, we are going to assume that the probability of getting an almond and a hazelnut is equal. How do I put this? When you're dealing with objects that are different shapes in a bag, some of them, just because of sort of the physics and geometry, are more likely to sort of go to the bottom, right? So we're going to disregard that for this question. Almost like assume that they're all the same shape, okay? What's the probability of reaching into the bowl and getting an almond? Yeah. Yes. 4 over 5. Okay, hold on. How many almonds are there in the bag? How many total outcomes are there in the bag? 18. Yeah. So this actually reduces to 4 over 9. Okay? This is 10 plus 8. And that's an important distinction to make because just as a little foreshadow, okay, the 4 over 5 will come into play when we look at odds, or the 8 to 10 will come into play when we look at odds. Okay? Kevin rolls a standard 9-sided die. What is the probability? Kevin rolls a number greater than 5. What's the probability of rolling a number greater than 5? Yes. P number greater than 5 is, well, this is 6, 7, 8, 9. So that's 4 outcomes out of 9. 4 out of 9. Okay. Now, to understand, so I think we have a good idea on probability. To understand odds, we need to remind ourselves what it means for events to be complementary. And we did look at this in set theory, okay, where we talked about complementary sets. But if two events are complementary, what do you think that means? Or can you think of an example of events that are complementary? Yeah?
Are complementary events that have the same odds happening? Or same probability of happening?
No, that's a good thought. So the suggestion was that they have the same probability. That's not necessarily true. Yes?
We're talking in relation to like the whole probability.
Mm-hmm.
In that case, it would be similar outcome events. Same outcome events.
Okay, let's review complementary set. Yes?
Wouldn't it be like the events that would like make 100% probability?
Yeah. So exactly. So in set theory, if this is A, what would A complement be? Yeah, the outside. Yeah. Exactly. Okay. So complementary events are events that have no overlap, but that make up the entire sample space. Okay, so for example, these two pictures, right? There's no overlap between the two things that I've colored in, but if you were to sort of overlay one on top of the other, the entire Venn diagram would be colored in. So there's no white space left over, okay? Remember that in set theory, you can describe complementary events by taking one event and putting the word not in front of it, okay? So, for example, rolling an even number, not rolling an even number. Those are complementary events. Okay. What about something like probability of rain and probability of sun? Are those complementary events? No. Yes, exactly. So not necessarily, because there's no overlap between those two events. It's not going to rain and, well, let's pretend that there's no rainbows. It's not going to be rainy and sunny at the same time, but rain and sun are not the only possibilities. It could be overcast, it could hail, it could snow, there could be a tornado, right? There are all of these other weather possibilities other than just rain and sun. So the key is that there can't be overlap and they have to make up the entire sample space. The entire sample space of weather is not only rain and sun. There are other things in there as well. Okay? So in general, because they make up the entire sample space, the probability of A plus the probability of A complement, what should that equal? 1. Yes. It's certain that one of those two things will occur. Okay, so, all right, are we good with that so far? Okay. Now, the reason why we're looking at complementary events is because we are going to be using an event and its complement to think about odds. Okay, now we're going to just do one question that kind of illustrates the fact that particularly the probability of an event and its complement equals 1, and then we're going to get to odds in a second. Okay, so 4 red marbles and 7 green marbles are placed in a bag. One of the marbles is selected at random. Okay, so firstly, the sample space. There's 4 reds, so 1, 2, 3, 4, and 7 greens. One, two, three, 4, 5, 6, 7. Okay. What is the complement of selecting a red marble? Describe it. Yes. In this case, the complement of selecting red is selecting green. You have to be careful, though, because if there was another color in the mix, then you'd have to include that color as well. So complement of selecting a green, you can always describe it by just using the word not. Not selecting red. Selecting red. In this case, you could also describe it as selecting green. But if there were 4 or 5 different colors in there, then, and you just said selecting green, that's not the complement because there'd be other possibilities than red and green. Okay? What's the probability of red? 4 out of 11, yes. Probability of not red? 7 out of 11. Probability of red plus the probability of not red is 4 out of 11 plus 7 out of 11, which is 11 out of 11, which is 1, which is just what we just kind of confirms what we just mentioned a minute ago. Okay. So far, so good? Let's jump ahead a little bit. And in fact, I think I want to skip this one. Let's take a look at this guy. Okay. The probability of event A happening is 0.36. The probability of event B happening is 0.64. Explain why A and B are complementary events. How could we know? Yeah. Yeah, their probabilities add up to 1. Okay, here's another one. Probability of rain tomorrow is 5 out of 11. Describe the complement of this event and determine the value of the complement. I think I meant to say the value of the probability of the complement. Let's describe it first. Probability of rain is whatever. What's the complement of rain tomorrow? Not rain tomorrow. Yes. Okay, what's the probability of not rain tomorrow? Yeah, P not rain tomorrow. Well, if we know they have to add up to 1, P not rain tomorrow is going to be 1 minus the probability of rain tomorrow. Right, which is 1 minus 5 over 11. 1 is 11 over 11. So that's 6 over 11. Okay, so far so good. Pretty straightforward, hopefully. All right. I think I'm going to skip this for now and move on to odds because I think these sort of simple probability questions, I'm getting the vibe that you guys are feeling quite comfortable with those. Is that correct? Do you guys want to practice a couple of these? Should we move on? Practice? Okay, take 5 minutes, practice these, and then we'll continue. Are not probability, okay? Odds are a ratio, and they're a ratio between the outcomes favorable to event A to the outcomes not favorable to the event A, okay? Which is why we sort of looked at the complementary events, right? One piece of the ratio is how many outcomes are favorable to this event versus the other piece of the ratio is going to be the number of outcomes favorable to the event's complement. Okay? So odds are a ratio of outcomes favorable to event A to outcomes not favorable to event A. Okay? There are 2 ways of describing odds. You can talk about odds in favor of event A. When you're talking about odds in favor of event A, the first number in the ratio is going to be the number of outcomes that are favorable to A. So this would look like this. A to not A. That would be the ratio when you're looking at odds in favor of. Okay. The other way that you can express odds is odds against. Event A. And odds against event A would be the same ratio in the opposite order. So you would write not A first to A. Okay? The way that odds are different to probability is odds are something called a part-to-part ratio. So you are looking at different parts of the whole, but the total never comes into play. Okay? And the total number of outcomes do not show up in odds. Whereas in probability, the probability of event A is the number of outcomes favorable to A over the total number of outcomes. Okay? So when we're looking at what is the chance of rolling a heads, and someone said 50-50, that's actually an odds statement, right? You're saying there's a 50 to 50% ratio of in favor versus not in favor. Whereas the probability would be 50 over 100. There's a 100% chance of one or the other happening. Okay? So just let's take a quick example. Okay, if you are rolling a die and we'll say six-sided, standard six-sided. And let's say event A is rolling a multiple of 3. Okay, so what I want to know are, what are the odds in favor of A? And what are the odds against A? Always a good idea to consider your sample space. Okay. Odds in favor of A. What do you think? How many outcomes are favorable to A? 2, 3, or 6, right? So this is the sample space. A is 3 and 6. Okay. So odds in favor of A means we put the number of events favorable to A first. So how many events are favorable to A? 2. What would the second number be? Not 6. 4. The second number is how many events are not favorable to A, right? If this is A, not A, or A complement, is 1, 2, 4, and 5. Okay, so not A is 4. Okay, or 1 to 2. What are the odds against A? Four to 2, right? Or 2 to 1. Okay, that total number of 6 never comes into odds. The total comes into probability, but not to odds. Yes?
So we don't use a fraction for this?
No. Good question. You don't use a fraction for this. That's an excellent question, actually. And that actually comes into a discussion around ratios. And when you're in, I think, grade 7 or 8, you learn about ratios and you learn about 3 ways of expressing ratios. You can write it as like 2 to 4 using the word 2, T-O. You can put a colon there, 2 to 4, or you can write it as 2 over 4. Okay? And we say you can always do all 3. The reality is, though, that in practice, we only typically use the fraction if it's a part to whole ratio. Part to whole is when you're looking at the total, right? That's why probability is expressed as a fraction, because part to whole would be like 2 to 6, 2 out of 6, okay? But yeah, when it's part to part, which is what odds are, we write them like this. Or you can use the word 2 there if you want, 1 to 2. That would be fine. Okay? All right. Let's look at some questions. If the Calgary Flames won 10 games out of the last 15 games and no ties were allowed, determine the odds in favor of the Flames winning the next game. Okay? Now, when you are working with odds, I always recommend that you write out the specific parts, because most of the time in the problem, you're not given the individual parts. You're often given one part and the total. But odds use part to part. Okay, so here's what I mean. If you look at this situation, there are wins, total number of games, no ties were allowed, so we can assume that the complement of wins is losses. If ties are allowed, we would have to use the word not win instead of losses. Okay, so we've got 10 wins, 15 games. How many not wins? 5. Okay, explicitly writing this out will greatly, greatly, greatly reduce the occurrence of errors when you're working with odds. Because it seems like a simple concept, but people see numbers in the problem and they just plunk them in. Okay, so the odds in favor of the Flames winning the next game, odds in favor is the ratio of win to not win. So this would be 10 to 5 or 2 to 1. Okay. The odds against the Flames winning their next game, odds against are not win to win, or 5 to 10. Okay, which is the same as 1 to 2. Okay. So I think what I'm going to do is get you guys to try these next 2 questions for a few minutes. We'll see if you're getting this concept, and then if we need to, we'll fix any misconceptions, and then we will keep going. You have to figure out odds. Or sometimes you'll get a question where you're given odds and you have to figure out probability. And my biggest suggestion is to always write out the number of outcomes favorable to A, the number of outcomes not favorable to A, and the total. And whether you're given odds or probability, you should know 2 out of 3. And if you know 2 out of 3, you can figure out the third. Okay? So I already sort of spoke to this. Odds are part to part. And so if you wanted to get the total, you'd have to add the 2 parts together. Probability is part to total. And so if you want to get the missing part, you have to take the total and subtract the 1 part. Okay? And you have to kind of understand that concept when you're going back and forth between the 2. So let's look at some examples. The odds in favor of a team winning their next game are 7 to 8. Determine the probability of the team winning its next game. Okay, so people like to jump into these questions because they think they're easy, but that increases the chance of careless mistakes. So what I would always recommend doing is this. If the odds in favor of winning are 7 to 8, what that means is that 7 is the wins. What does 8 represent? The not wins. So then what's the total? Yes. If you write this down, you will never make mistakes. Okay? Probability is out of total. So what's the probability the team will win its next game? P win, 7 out of 50. Okay? Probability it does not win its next game. Eight out of 50. Okay? Questions with that? All right, you guys try these ones. Type is you're given the parts and they ask for odds. That's the easiest, because if it's like there's 4 blue marbles and 5 red marbles, the odds in favor of blue are 4 to 5. So you're given the parts, you're asked for the parts. The other type of question is you're given the parts and you're asked for the probability, right? So if the odds are 4 to 5, what's the probability? It would be 4 out of 9 because 4 plus 5 is 9. Okay, the most sort of challenging question, or the one where people sort of got a little bit stumped, is when you're given probability and you have to figure out odds. Okay, so really important, odds in favor and odds against. When you have probability, you have A over total, right? So PA is A over total. Number of outcomes favorable to A over total number of outcomes, right? Odds in favor of A are A to not A, right? And odds against are not A to A. Okay? So the tricky part is that if you're given a probability, you're not given the not A part. You have to figure that out. And it's probably easiest to see how this would work by looking at an example. Okay? So if the probability of rolling a composite number on a 6-sided die is 1 over 3, what are the odds in favor of rolling a composite number? Okay? Now, because this is a 6-sided die, we could actually start from scratch, write out the sample space, and work this out ourselves. You don't always have that option, though. Okay? So let's do that in this case, and then also talk about how could you go directly from the probability to the odds. Okay? So if we're looking at a 6-sided die, okay, the composite numbers are numbers that have 3 or more factors. So which are the composite numbers on a 6-sided die? 6 and 4. That's right. Okay, so those are the composite numbers. You can see why the probability is 1/3 because it's 2 out of 6. Okay, odds in favor of composite would be how many composite to not composite? Yeah, so this is 2 to 4 or 1 to 2. Okay, now, if you can't write out the sample space though, you have to work right from the probability, right? In this case, because we know what the sample space is, we didn't even need to know what the probability is. We could just write out the sample space and figure it out ourselves. So the question is, what if you're just given probability? You need to think about probability this is A, this is total. So if it's 1 is the A and 3 is the total, how many would be the not A? Yeah. It's 3 minus 1, which is 2. Okay? And so if we're looking at odds in favor of, we're looking at A to not A, that's a 1 to 2 ratio, which is exactly what we just saw. Okay? And we are going to have to use that when we can't write out the sample space. Okay? So let's try one more. The probability of a team losing its next game is 3 over 7. Determine the odds against the team losing its next game. Okay, so there's a couple things that I would do right off the bat. Probability is 3 over 7. And we're looking at the probability of losing. So this is losing. This is total. How many is not losing?
4.
Yes. So not losing is 4. You need to clearly see those distinct parts. Okay, so that's one thing that I always do when I'm working with odds and probability at the same time. Write out the number for each part and the total. Okay? Second, probability of a team losing is 3 out of 7. Determine the odds against losing. So when I see odds against losing, before I start putting numbers in, I write odds against losing are not losing to losing. And I write that down first. Okay, and that would be 4 to 3. Okay. Here's why it gets tricky and people make mistakes if they don't write that down. Okay? Odds against has a negative connotation. Losing has a negative connotation. So when you think odds against losing, a lot of people put losing first. In this case, that's not true. Losing is the event. Odds against losing is not losing. That needs to come first. So when you clearly highlight or underline the words odds against losing, the next thing you do is write not losing to losing. And then you just look at the numbers that you analyzed over here, plug them in, and you will never make a mistake. Okay? Does that make sense? Yes? No? All right, cool. So I would like you guys to complete these 4 questions now. And then these questions are for homework. So I'm going to end the video here.